this many ways. You could find solutions to quadratic equations by completing the square. You could do it by factoring, and you could also do it by the quadratic formula, which is what it's how we're going to go about finding them in this video, is using the quadratic formula. So before I start doing examples, let me go ahead and derive the quadratic equation for you, so you can get a sense of where it came from. Now here I have a quadratic equation in standard form, and the zero is already on one side, so I'm going to go ahead and derive the quadratic formula using this equation. So the first thing I'm going to do is go ahead and divide this coefficient off the leading term. Don't forget the zero. So then you get x squared plus b over a x plus c over a equals 0. So now I'm going to go ahead and complete the square. So I'm going to subtract this constant over. So then I get x squared plus. Now I'm going to leave a space here. I'm going to subtract the constant over. And then I'm going to leave another space because when you complete the square, you have to add that term onto both sides. So to complete the square, we're going to take this guy right here, whatever's in front of this variable to the first degree. So it's b over a. We're going to multiply that by 1/2, and then we're going to square that. That's the term that's going to get added onto both sides. So this will become b over 2a. And when you square that, you get b squared over 4a squared. So this is the term that I'm going to add onto both sides. B squared over 4a squared. B squared over 4a squared. B squared over 4a squared. Okay, so now whenever you complete the square, it factors nicely. So I'm going to go ahead and factor this side. It's going to become x plus b over 2a squared. That's how that factors as. And then on this side, let's go ahead and get an LCD. So the LCD looks like 4a squared. So I'm going to multiply the top and bottom of this fraction by 4a. Okay, so now we have an LCD of 4a squared, and on top, this will just all multiply, so you'll get a negative 4ac plus b squared. Okay, I think I'm going to have to move on to this side now because this derivation is kind of long. Okay, so now we're trying to solve for this variable x because everything else is a constant here, right? A, b, and c are constants. So I'm going to go ahead and take the square root of both sides right now. So I'll take the square root over here, and I'll take the square root of this whole thing. Okay, on this side we just get what's inside the parentheses, which is x plus b over 2a. And on this side, since we're taking the square root, we got to count for the plus and minus, right? So we get plus or minus the square root of, now I'm going to write this b squared first just because that looks cleaner instead of starting off with a negative. So I'm going to write b squared minus 4ac. Okay? And this is going to be all over. The square root of 4 is 2, and the square root of a squared is a. So that's all over 2a. Okay, still trying to solve for x. So all you have to do is just subtract over the b over 2a. So I get that x is equal to plus or minus and now I'm going to subtract over the b over 2a. Okay? notice that we already have an LCD of 2a. So let's just write it as one single fraction. So then we finally get that x is equal to, I'm going to go ahead and write the negative b first. So negative b plus or minus the square root of b squared minus 4ac, and that's all over the new the LCD, which is 2a. And that right there is your quadratic formula. So the quadratic formula is x, which is our solution, that's equal to negative b plus or minus the square root of b squared minus 4ac, and everything's over 2a, not just the square root part. So now that I've derived it for you, we're going to go ahead and use it. Alright, so actually before we start doing some problems with the quadratic equation, I wanted to mention something to you about the quadratic equation, which is the discriminant. It's the part that's under the radical. So the discriminant is just this guy right here. So the discriminant is b squared minus 4ac. So I'm just going to refer to the discriminant as d. So here's the three cases that you'd expect when using the quadratic formula. The discriminant's going to shed some light into our solution. So you have d here, right? If d is greater than 0, we're going to expect two real solutions. If d is equal to 0, we're going to only expect one real solution. And if d is less than 0, then we're going to expect two complex solutions, because the discriminant, we said, is what's under the radical, right? So if you get something that's less than 0 under the radical, that would be negative. And when you have a negative under the radical, you get complex solutions with i's and stuff, right? When the discriminant equals 0, the square root of 0 is 0, so we get rid of the square root part, and we only get one solution. And when it's greater than 0, the square root remains, and therefore the plus or minus, or however it happens, we get two solutions. So yeah, that's a discriminant. And just beforehand, if you don't want to do the whole process, do the whole quadratic formula, you can just jump straight to the discriminant, just to know ahead of time what kind of solution you'd expect. Alright, so we're going to go ahead and do the first example here. Here's the example right here, and the directions are to solve this using the quadratic formula. So you need to know what a, b, and c are before you jump into the quadratic formula. So here I've written out the standard form of a quadratic equation. And you do want to get it in standard form before you start. It'll just make it easier for you. You don't have to, but it'll just make finding a, b, and c easier. So here I could see that b is 2, c is 8, and a is 1, right? A can't just be nothing. So we figured out a, b, and c. So we got that a is equal to 1, b is equal to 2, and c is equal to negative 8. And I'm going to just go ahead and just plug and chug all that into this formula and see what happens. So we get x is equal to negative, my b was 2, plus or minus the square root of b squared, our b was 2, minus 4, a was 1, our c was negative 8, I believe. Okay, and this is all over 2 times a, which was 1. So then we get that x is equal to negative 2 plus or minus the square root of 4 minus 2 negatives make a positive. 8 times 4 is 32. And this is all over 2. So then we get x is equal to negative 2 plus or minus the square root of 36 all over 2. Get x is equal to, the square root of 36 is 6. So we get negative 2 plus or minus 6 all over 2. Now this is like, these guys have the same LCD. You could split up the LCD if you like. If that's how you like going about it. Or you could just see that you're really just going to divide this 2 into the negative 2 and to the 6, which is actually what I'm going to do. Or maybe I should write it out first. So you could write this as negative 2 plus or minus just split up the LCD if that's if you're more comfortable doing it that way. Okay. So then you get x is equal to, this will become negative 1 plus or minus, and that will become 3. So now the place where the plus or minus comes in is you have to you can just write out 2 different solutions for this. So one of our solutions is going to be x is equal to negative 1 plus 3 from the positive root, and the other one's going to be x is equal to negative 1 minus 3 from the other root, from the negative root, or whatever. Okay, so this 3 minus 1 would be 2, and this would be negative 4. So the 2 solutions I got for this were x equals 2 and x equals negative 4. So notice that we got 2 real solutions and they were rational, which means that we could have factored this instead of going by doing the quadratic formula. But this was a good example.